Hi, I'm Paul Lacey with Power Integrations. I'm here to introduce the next generation of our best-selling TOPSwitch family, TOPSwitch-JX. The accelerating trend in the power supply industry is towards higher and higher efficiency and extremely low no-load and standby consumption. TOPSwitch-JX is an integrated MOSFET and controller for flyback power supplies that provides the highest efficiency over the entire active load range and minimizes consumption in no-load and standby modes. With TOPSwitch-JX, you can meet demanding efficiency requirements. Here's a chart illustrating the relationship of input power to output power for a 27-watt TOPSwitch-JX design operated at worst-case input voltage of 265 volts AC. Notice how the curve is very linear above 100 milliwatts of output power. This is due to the constant level of efficiency provided by TOPSwitch-JX over the entire active load range. Let's look at no-load performance, one of the most difficult specifications to meet. Notice that the design has very low consumption at the left end of the curve. Now take a look at the reference design board, which corresponds with our power chart. When the supply is running at 265 volts AC input with all loads removed from the output, the wattmeter measures an input power of just 65 milliwatts. Standby performance is a key consideration in most designs, and manufacturers are beginning to enforce a 100 milliwatt input power limit during standby. This makes it extremely important to maximize output power for a given input power limit while in standby. More output power in standby makes system design easier, and TOPSwitch-JX delivers, providing 30 milliwatts of output power while staying under the 100 milliwatt input power limit at 265 volts AC. TOPSwitch-JX's high light load efficiency enables it to provide more standby power for all applications. For example, new EUP Lot 6 standards require consumer devices to maintain a standby input power of no more than 500 milliwatts. It can be a difficult specification to meet with some power-hungry products, but our TOPSwitch-JX design is able to deliver 350 milliwatts at this limit. Now let's move out of no-load and standby into the active loading region. The slope of this curve, power out over power in, is also the efficiency of the supply. This curve becomes very linear as output power increases, holding the slope almost constant. That means our TOPSwitch-JX supply has constantly high efficiency over the entire active load range. The unique no-load and standby performance in TOPSwitch-JX designs is made possible by several integrated features. Jitter lets you design with a smaller X capacitor that doesn't require discharge resistors, completely eliminating those lossy components. TOPSwitch-JX also dramatically decreases control pin current, minimizing controller consumption down to just 8 milliwatts. This reduced current also lowers both primary and secondary feedback losses. Line detection consumption is reduced, and by using TOPSwitch-JX's multi-cycle modulation mode to maintain output voltages at light loads, transformer and output diode snubber losses are substantially reduced. Obsolescent burst mode designs conduct a large number of switching pulses between long sleep intervals. MCM mode only conducts cycles when necessary to support the output voltage. This reduces switching losses at no load and standby. It also reduces the output voltage ripple at no load, which is a difficult spec to meet in burst mode designs. TOPSwitch-JX power readings are very stable with temperature. See for yourself. We measured the no-load input power of our reference design at room temperature, 0 degrees Celsius, and 50 degrees Celsius. There's a total difference in input power of just 7 milliwatts over the entire temperature range. We also see only 5 milliwatts total part-to-part variation during production runs. This tight level of control allows safe design with limited margins. These tight tolerances are possible because, unlike burst mode, the MCM mode used in TOPSwitch-JX isn't dependent on parasitic elements to determine no-load and standby performance. By reducing power consumption, as well as limiting temperature and part-to-part variations in dissipated power, TOPSwitch-JX substantially increases your available standby power budget over traditional burst mode designs. TOPSwitch-JX features an integrated 725 volts DC power MOSFET. This gives you more safety derating in your existing designs. It also reduces the size and cost of your output diode while increasing efficiency. The peak inverse voltage stress across an output diode is directly related to the reflected voltage of the transformer, which is in turn limited by the breakdown voltage of the MOSFET. With TOPSwitch-JX's 725 volt MOSFET, you can increase the reflected voltage to proportionally decrease the voltage stress across the output diode. Then you can increase the efficiency of your design by using a diode with a lower VF, which is often a smaller, less expensive component. TOPSwitch-JX features a very high level of product integration, removing many of the discrete components that used to be required in flyback supplies. This cuts down component count, increases reliability, and reduces board size. It also speeds time to market by dramatically simplifying the design. This performance comes packaged with our standard set of protection features, including output over voltage protection, a safe shutdown mode for broken feedback loops and output short circuits, and hysteretic thermal shutdown. TOPSwitch-JX is available in both eSIP and our new low-profile eDIP package. The large number of source pins on the eDIP package improves thermal coupling to the board for better PCB heat sinking. The exposed thermal tab also reduces thermal impedance and allows you to easily add a heatsink. Straight leads and reduced plastic thickness give eDIP a much lower profile over a standard PDIP package. At the same time, standoffs on the bottom of the package provide physical clearance from the board for flux removal and cleaning. The eDIP package provides 3 mm of clearance between the drain pin and the nearest low voltage pin, and 1.8 mm between the drain and any optional heatsink. This makes PCB layout easier. All these improvements make the eDIP an ideal package for low-profile designs like slim laptop adapters and LCD monitors. TOPSwitch-JX is your best solution in addressing the challenging new regulations facing the industry. Today we've seen it substantially reduces no-load consumption and has high efficiency over the entire active load range. For more information, including datasheets, design examples, and training courses, please visit the TOPSwitch-JX page on the Power Integrations website.